Hello, this is Jason Kendall, and we're going to be watching the Perseid Meteor Shower this year, August 12th, the night of the 12th into the 13th, 2023. But with this, even though it's for this year, it also applies to next year and all the other years, considering what the Perseids are. This is important because people like to go out and watch meteor showers. So how do you do it? What do you need to do? What do you need to bring with you? And everything like that. So this picture is watching the Perseid Meteor Shower in New York City in Inwood Hill Park. And this was a wonderful event I held some years ago. And people are actually being able to see the Perseid Meteor Shower way up in the sky there. And stayed late, and even the park's personnel and the park rangers were okay with it. I'm not sure if they'll be okay with it today. I wouldn't really try it. But New York City used to be able to see the Perseids, and I've seen them all. I've seen Geminids there as well, and it used to be some great stuff. You can look in this particular picture really close up. You'll see the constellation of Andromeda at the center of the sky above, which is kind of like a bent triangle. But they'll be looking pretty much high in the sky. Their eyes are looking up in the right direction to see the Perseids. So what are the Perseid meteors? What we should look like for things like this. Flashes of light in the sky. This is a Perseid meteor shower over Israel. We can see other ones like this, one that's in Iran. Beautiful flashes of light through the sky. And finally one we can see in like Virginia. So we're going to see bright flashes of light in the sky that last less than a second. Well, you can do these kind of star parties in lots of different locations. I've done a few of them everywhere, and this is in New York City way back in 2010, where I did with Michiu, Kaku, and BBC. And there was some wonderful things we did way up there on the top of someplace down on 23rd Street. So as you can see, the city is bright. So even if it is bright, you can go way uptown to Inwood Hill Park in northern Manhattan, and this is some gear I used to have, a 15-inch obsession telescope, ultra compact, and I used to carry it up with an electric cart all the way to the top of a hill in Inwood Hill Park. If you know where to look at this hill and you're smart, you can figure out where this hill is by looking at a map of Inwood Hill Park in Manhattan, and that is a good spot to look for meteors. I would suggest going there, but you better bring bug spray and you better wear some pants. Anyway, let's talk about the meteor shower itself. So first things first, meteor terminology. We need to know all of our terms for meteors. Well, comets are objects from which almost all meteors arise. They're pieces of ice and rock and dust and frozen gases, and as they get closer and closer to the sun, they disintegrate, fall apart, and leave behind bits that then the Earth passes through, and we see them as meteors. Some things, asteroids, small rocky bodies, iron and somewhat ices, they're flying around in space, orbiting the sun. As they orbit the sun, they mostly orbit between the orbits of Mars and Jupiter. And as we look for them, we might see that they're pretty big. Some range from meter up to many kilometers of size or hundreds of kilometers in size. They can be quite large. But most of the meteors that we will see do not come from asteroids. A meteoroid is a really, really, really small chunk of an asteroid. It's usually microns in size, up to about a meter. That's what we call a meteoroid. And these things are potential meteorites. So a meteor shower in the lower left is what we're going to be talking about, and a meteor is the light that's emitted from a meteoroid or an asteroid as it enters the atmosphere. So a meteor is the light flash in the sky. A fireball is when that meteor is extremely bright, and in fact brighter specifically than the planet Venus in the sky. And a bolide is an extremely bright thing, a large asteroid or meteoroid that impacts, and it explodes. It explodes because it's going really fast, heats up, and it breaks apart, rather than disintegrating like a meteoroid or a larger fireball. All right. Finally, meteorites. Meteorites are things that survive the impact to come all the way to the ground. So a meteor is the flash that you see. A meteoroid is a rock that is orbiting the sun and may or may not intersect with the Earth's orbit and therefore go through its atmosphere. And a meteorite is on the ground. So oid in the sky or in the air, ite on the ground. So when do I go out to see the Perseids? In 2023. The peak is on the night of August 12th through the 13th. Night of the 12th morning of the 13th. It'll be a good night because on this night the moon will be 10% full. So it doesn't even rise till about 3:30 in the morning, so that will be great. How to see a meteor shower? First and foremost, the weather. It must be completely clear, especially if you're close to an urban environment, but it really helps for it to be totally clear sky. No clouds, not just holes in the clouds, not just a cloud here, just get rid of the clouds. Partly cloudy's out, it needs to be really clear, rain is gone, don't even look up at the sky, just get away from the clouds. Try to drive as far as you can. But I strongly suggest you use these resources, the Clear Sky Chart, which I put an insert in below, so Google Clear Sky Chart, and I'll put a link in the video below. Also, look at this NASA satellite, the NOAA GOES satellite, or not satellite, look at that silly typo I got there, but that satellite will show you where the cloud cover is over the United States. And then that's part of the National Oceanic Atmospheric Administration, which gives you a very, very good weather forecast. In fact, it's where everybody gets their weather forecast from. So you might as well look at the source, which is a great place. So must be clear sky. Next, how are we going to see this meteor shower? What time do we go out? You have to go out well after 10 p.m. Don't try to go early. Don't try to do it so you can go to bed by 10. You're not going to see them. Meteor showers do not begin in full until after 1 o'clock in the morning local time. And they'll be over roughly, for most viewers, at roughly 4 a.m. This is specifically for the Perseids. And specifically this time, it'll be over due to the moon. So your best bet is stay up all night to see them at their best or to get any chance at all. And so your best bet is to go see them in the hours before dawn. Why must we go see them at this time? Why can't you see them before? Because as the Earth goes around the sun, if we look down from the top of the orbit of the sun, Earth around the sun, if we look at from above, we'll see that the Earth appears to orbit the sun counterclockwise. And we would also notice the Earth is spinning on its axis counterclockwise as viewed from above the Earth's North Pole, above the sun's North Pole, and watching them both. So what you want to have is the leading edge of the Earth, meaning where it's plowing through in the orbit, be at the same place where darkness is. And the only way for that to happen is for it to be past midnight, because then you'll be on the leading edge of the Earth as it's going in its orbit. Before midnight, you will be on the trailing edge of the Earth in its orbit. And so just think about it like this. If you're driving down the road and there's a whole bunch of bugs, you drive through a bug swarm on there, you're going to run into a lot of bugs on your front windshield, not on your back, not on the back rear windshield, and not on the side windows. Back window, rear window, nothing. Side windows, no bugs. Front windshield, gonna get bugs. Why? Because that's the direction you're going. Okay, so how to see it? Basics. You must go to a dark place where you can count the stars. You must be able to count them. Not 1, not 2, not 10, but try to lose track at hundreds of stars. If you can't see hundreds of stars, I mean actually hundreds of stars, then you won't be able to see them. So go someplace dark. Make sure there are no street lights visible. Even if you lie down and look straight up, they cannot be visible to you from the side, from any direction. Make sure the nearest street light is at least a quarter mile away. Get rid of those security lights, car headlights. Get away from them. They've got to be far away and out of your field of view. You must have a clear view. It's best to have a clear view of all the sky, nearly all the sky. Only go to a tree-lined area if it helps block out light. So you're going to be looking up. You're going to stay warm. You're going to try to not get bit by bugs. And primarily, you must have patience. This really is important today and to know, and I'll tell you why later. You got to have patience. You're going to be out there for hours. You need to just kind of sit, look up, and be patient. So what do you want to take with you? Well, it might be 80 degrees out because it's summer, but you will need to dress for about 20 degrees cooler than it says Fahrenheit. Wear long pants, wear shoes, wear socks because bugs, and bring a light jacket that covers your arms because, well, bugs. And bring some food and water, cocoa, coffee, tea. That's a great thing to bring, little light snacks. You know, try not to bring a lot of sugary foods because you'll get a sugar crash. That's not cool, because then you'll fall asleep because you're getting a sugar crash. Proteins and fats are pretty good for helping you maintain your ability to stay awake. Next, you're going to want to bring a star map or planisphere, and I'll show you what those are in a second. And most importantly for your eyesight, because you got to get around to the dark, right? You need your flashlight must be covered with a red gel or covering filter, either red cellophane, red piece of paper. Cover those lights, cover those lights, cover those lights with red. That will help you keep your dark adaptation. That's very important. Next, leave the alcohol and the recreational herbs behind. Just leave them behind. They're not important. This is not what you're doing tonight. You're not drinking. You are not doing funny, silly things. This is a nature event. It's like you're going hiking in the wilderness, not like you're sitting around your friend's apartment having a good time, okay? Right. Next, blanket or lawn chair where you can lean back and look straight up. That's really important because you've got to stay comfortable. If you try doing this standing, you're done. If you sit on the bare ground, you can get bit by bugs, and nobody wants that, or your pants are going to get dirty. That's never any fun. Your hands are getting dirty. So get a blanket, get a long chair. If you can't get that, blanket's minimum. It's just all you need. Even if it's a towel, take a towel with you. That'll work too. So let's look at these star maps and planispheres. I suggest these two. I love the Guide to the Stars map by Ken Grant. That's fantastic. You can get it off on Amazon for like 15 or 20 bucks. That's fantastic. This is an excellent guide to the stars. Also, the Sky Maps, Evening Sky Map, and I'll leave links to both of these in the description. That's free, and you can just print that out and say, oh, what's in the sky? This is a fantastic resource. Both of these are excellent, and they help you understand and get oriented to the night sky. You got to get one of these, and you also have to make sure your flashlight is covered with a red gel. Really. But now, here's one of the most important things that you will have. You can do this with a star map or planisphere. All you have to do is look up. But you really have to leave your phone in the car. Leave it in the car. You will not see any meteors with your phone. You can't take a picture of them. It's not possible. Don't try. That's just, it's the height of what you should not do when you're trying to do meteor watching, is to try to take a picture with your phone. First, you will lose your dark adaptation and not see any dim ones that your friends will see because you're looking at your phone and your phone is bright. I don't care. Oh, I got it on dim. I got it on really low. No, it's too bright. You've already lost your dark adaptation. You're done. Just turn it off. No, I'm serious. Turn it off. We live in a technological age. Of course, you're watching this on YouTube. You're trying to learn stuff. You probably have seen thousands of things. You're probably flicking through your phone all the time or your computer all the time. This is the time when you wish to shut things off and just enjoy nature for what it is. Remember, it takes about an hour for you to become fully dark adapted, and that's completely and instantaneously removed by looking at a phone or any light much brighter than starlight for even a second. So if you just flick it out and say, oh, I gotta look at this, you're going to lose your dark adaptation for about an hour, and you will not see meteors for an hour. This is what makes it sad, because there's never any warning about when a meteor shows up. They just appear. They're quiet. They're flashes of light. They're faint. And so when someone says, wow, it's already, and you didn't see it, it's already too late. You've already missed it. And if you're not dark adapted because you insisted on looking at your phone, then you'll miss out on the whole thing. So keep that phone in the car or away and turn it off. Like you're going to the theater. No, really, like you're going to the theater. Like you're going to a movie and you're not trying to be rude to people around you. Like you're going to the opera. Like you're going to the concert. Like you're going to your grandmother's house and she says, put that phone away, we need to talk. That kind of thing. Remember, nature will unfold in the way that she wishes to. There are mysteries of nature. This is a beautiful thing to engage in. It's lovely. I'm sounding like a crank, but I'm not. I'm just trying to help you understand that there's some beautiful things in the natural world, and there's ways to experience them. And this is the way to experience them. It's not going to hurt to leave your phone behind for a night. It'll be beautiful. You'll love it. It's a fantastic thing. So, what are you going to look for on your meteor watching night? With your lawn chair, or sleeping bag, or camping chair, or whatever, just relax. Look back. look about 45 degrees above the horizon. Your field of view will scan, just scan very gently. Don't dart your eyes around, just scan gently, roughly in the direction of the shower's radiant, which I'll show what that is in just a minute. The best point about this is that, well, you can look, well, is that you're just kind of you don't have to stare hard. You don't have to really hunt. You just have to be ready and simply relax. So what you want to do is just watch around 30 degrees away from the radiant point for a shower. And a way to think about 10 degrees, 45 degrees, what that is, take your fist at arm's length, and your fist straight out is about 10 degrees. So stack your fist up 9 times in front of you, and you'll get to straight overhead. So 10 degrees is about the angular size of your fist held at arm's length. Put each fist on top of each other, you'll notice you get 9 fists to go to the top. Just try it, you'll see. Okay, next, where do you look? So the Perseid Meteor Shower is in the northeast of the sky, and we call it, and this is using Sky Smart's planetarium software, which is a really nice planetarium software. You're looking in direction of the constellation Perseus, north of east, so you find the Big Dipper and look up and to the right from that when it's approximately 1 o'clock in the morning. So the Big Dipper will be very, very low in the sky. A bright star over in the east will be Jupiter. That will be rising. And if you look close to the horizon, you'll also see something directly below it. That's the bright star Capella. Capella is a very bright star, and it'll be directly below the radiant of the Perseids. So roughly in this general area is where you're going to be looking. The lines that you see in this simulation, that's not what you're going to see. This is if you'd had a meteor storm coming from there. There is no prediction for a meteor storm from the Perseids at this time. You're not going to see this. But if you were able to take a recording of all of the Perseids over the course of a night and had extraordinary sensitivity, this is what you might actually see over a long period of time. So why does it look like this? Because the meteors do appear to radiate from this central place. And the farther they are from the radiant, the longer the trails are that you will see in the sky. Why is that? It's the same exact reason that if you're driving a car late at night or at nighttime in a snowstorm, you will see an effect like this. Notice how you're driving straight in front of you, right? And there are lines off to either side, and those are snowflakes. Now you know that the snow is coming down. Let's just, because I don't see much of an angle to them. That means the snow is coming almost straight down. And if the snow is coming straight down, but the car is going forward. So this is the sum of the vectors between the direction of the snowfall and the direction of the car's movement. The car is moving a lot faster than the snow is falling, so it also appears that the car is running into the snow. So the radiant in this case is directly in front of the car, and the farther away from the radiant it is, the longer the streaks appear to be. But we do know that the snow itself is simply falling straight down. So this effect is completely due to the fact that the Earth is going through the meteor swarm. That's all it is. That's exactly the reason. So as the Earth moves through, you want to make sure you get the maximum effect for this, and the only way to get the maximum effect for this is, of course, looking at the front of the car, or in this case, when you're on the side of the Earth that is in the direction of the orbit of the Earth, which means after midnight, roughly 1 o'clock in the morning till about 4 o'clock in the morning. So, what to look for? Let's give you some more terms. There's some terms like horizon and zenith angle and altitude and air mass. Let's look at what those mean. So the zenith is the point that if you lie on your back and look straight up, that's your zenith. The horizon is looking directly 90 degrees across. You know what the horizon is, but this is the formal definition. The zenith angle is the angle away from the zenith down towards the horizon, and the altitude is the horizon up to the zenith. Air mass is how much air is between you and the top of the atmosphere. And the lower that you're looking at something in the sky, the more air you're looking through, and so therefore the air mass is greater. More meteors can be seen as the radiant gets higher in the sky, meaning its altitude increases or its zenith angle decreases, because of two reasons. One, as the light goes through the horizon, if it's low to the horizon, and it goes through the horizon, what am I talking about? If the light from a meteor it comes from the radiant when it's low in the horizon, then it has to go through a lot of air, which dims the meteor. Also, it's farther away, so it looks dimmer. So most of the meteors happen very far up in the altitude, roughly about 40 to 50 miles up. So they don't make it to the ground. So they basically get burned up very high in the Earth's atmosphere. So this blue line is very corresponding to where you could think about the. I mean, it's a good analogy to where they're impacting. In any event, you want to get it so that the radiant is as high in the sky as possible, and so that means better viewing goes as the night goes on. And so we can see we started this simulation, started roughly around 9 o'clock or 10 o'clock at night, and it gets about 30 degrees at about midnight, and it gets about 45 degrees around 2 in the morning, and almost up to 60 degrees at 3 in the morning, just as the moon rises in the east, and it gets to about 60 degrees at about 4 o'clock. So once again, this is the path of the Perseids as the night progresses. It goes from roughly north to almost over due northeast, and it gets higher and higher in the sky, which means as the night goes on, you are looking through less and less and less atmosphere, which means they're physically closer to you, and the light from the meteor is attenuated less and less and less because there's less atmosphere for the light to go through. So you're going to be looking for the Perseid meteor showers as the light goes on. So you just get up about midnight, take an early nap, go out about midnight, get to that place around 1 o'clock, stay for 1 o'clock till about 4 a.m., and have a great morning. You're going to be wiped out, but that's just exactly how you have to do it in order to truly see the Perseids. So if you want to take your kids out, put them to bed early, get them at 1. It's going to be a fun night. Or take a date, or just go out on your own. Have a great time. So where exactly do you wish to go? Locations, and because I live in New York City, I'm going to give you some places in New York. First and foremost, an old favorite, Inwood Hill Park, north end of Manhattan. However, all New York City parks close at about 1 o'clock in the morning. Your city may probably do the same thing. I would imagine almost all cities do such things with public parks. So do check your local ordinances to make sure you're not going to get arrested or get a fine by the police officers, because that would be no fun. You don't want to be arrested or taken away because people say, "Oh, you can't be out here at night, kid." It's like, that stinks. But in Inwood Hill Park, they have a curfew at 1 o'clock, but yeah, you can still go if you want. City beaches, go far. Go to these far beaches way outside of town. Those are great places. It might be here, it might be there. You never know. If you have a wooded park nearby, even farmers' fields deep away from the town, that's always good too, because that gives a lot more light. But farmers' fields probably have security lights from nearby farms. And if you do have security lights from nearby farms, you can't turn those off. You can't go to the farmer and say, "Turn off your security lights." They'll never do it. So you probably will have to bring something to help block some light, maybe the side of your car or something like that, or even a blanket or something where you'll lose a little bit of the horizon, but only like 10 degrees because you might be lying down or something. So you can plan it. For another place in New York City, there are bad places to go, such as Brooklyn Bridge Park and Central Park. You will not see them there. You will not see them anywhere there. You will not see them at the top of the Empire State Building. It's not going to help. It's totally bright. And this applies for all major urban areas, no matter where you are in the world. Get out of the city. You will not see any meteors in any urban environment to save your life. Somebody says you're going to save your life if you do this. It's like, I'll try. It's like, you'll fail. So don't do it. Find big parks such as Van Cortlandt Park in the Bronx, which is a parade grounds, extraordinarily big, and it helps. That actually would be a good place. Also, the other side of New York City, in Staten Island, Great Kills Park, you have most of the ocean on the other side, so it's fantastic. Now let's go a little further away from New York City. And you find in the suburbs, Ward Pound Ridge Reservation, the good people over at Westchester Amateurs Astronomers Association have a wonderful place they go to in Ward Pound Ridge. It's a great spot. It's a dark sky location. It's about 50 miles north of the city. and you'd have a great time if you get out there. They do have an all-night party, which I'll show you a little bit more about in just a second. Also, Western New Jersey, Jenny Jump State Forest with the United Astronomy Clubs of New Jersey. They'll probably be doing something, but call them up, look at their website, see what they have to say. Maybe out on Long Island, look on the Palisades Parkway. But this is New York City, but let's see a little bit further afield. So in and around New York City, there's a lot of places that you can go in order to see things. Now it's more like general. Wait a second though, look at all these places, all these markings of people that are doing events and clubs near New York City. This is New York. There are places all over the United States. And I'm just looking at this area from Boston all the way down to Washington. There are groups and groups and groups. And these are beautiful things to take part of, and you can learn more about them by going to NASA's Jet Propulsion Laboratories Night Sky Network. Look that up. Google that. These astronomy clubs are there for you to learn about astronomy. Look at the Night Sky Network. You will find all sorts of things. And in fact, if you can't even do that, check this out. Here are some dark sky locations, designated dark sky locations by the International Dark Sky Association. There are 3 little markings that have up in the upper west, the northwestern Pennsylvania. That is Cherry Springs State Park, an international dark sky location. The other places I've circled that don't have anything in New Jersey and the Catskills and Montauk, those are great places too. The top in northern New Jersey, in that green area, that is where Jenny Jump is with UACNJ, and the New Jersey Astronomical Association is right below it. And there's some beautiful parks down in southern New Jersey on the waterfront, and all the way down to Bella Plaine State Forest with the Southern Jersey Astronomy Club. You can also see some other dark sky locations to the west of Washington, and I invite you to go look at the International Dark Sky Association's website. Go look at their stuff. They will show you truly dark locations all over the world, and not just the United States. NASA's Night Sky Network is a fantastic place to go in order to learn where to go to see those meteors, no matter where you are in the United States. They also have, I believe, some things outside the US, but that's going to be not as much. Not even really as much. So NASA's Night Sky Network, and they have a calendar, they have a map, everything like that, and clubs will advertise. And these are some wonderful people who just wish to show you the sky. And they'll show you the sky, and usually, almost always, for free. It's just one of these wonderful things about the hobby. You will go there and people say, let me show you the stars, and they do with their telescopes. It's kind of fun. There will always be all sorts of astronomy clubs everywhere. New Jersey and Pennsylvania, the Royal Astronomical Society, Scotland, Wales, London, everyone. Wait a second, hold on. London? Yes. Here are some dark sky locations near London if you happen to be in London. Look south of there, that's the South Downs National Park. There's some other dark sky preserves all across Ireland, Great Britain, and I didn't even get to the point of looking at Scotland. I kind of cut it off. That's sad. I shouldn't have cut off Scotland there. In any event, there's lots of places to go there too. And I know I've got a couple of subscribers from China, so there is a dark sky community near Hong Kong. So if you live in Hong Kong or you're in China, you can certainly go to Xicheng, Shenzhen, which is actually China's international dark sky community, recognized by the International Dark Sky Association. So that's fantastic. But these are designated locations all across the world. I suggest you go check them out to see where you can see truly dark skies. Now then, what are you going to look for on your meteor watching night? Most meteor showers don't show these boom displays. It's not going to be a Michael Bay movie where there's explosions going everywhere and Mars is coming closer and closer and flying around and there's bats going everywhere, cats and dogs living together, total mayhem. It's not going to be that. It'll be quiet, it's going to be patient, there'll be a few, and look at those numbers. Look at the numbers on August 12th to 13th, the predicted numbers, and this comes from the American Meteor Society, amsmeteors.org. 10 meteors per hour from a city area or rural sky with the full moon. So you'll be lucky to see 10. Lucky to see 10 if you're in the city per hour. You'll be lucky. If you get out of the city, you'll see roughly 50 an hour, almost 1 per minute if you're outside the city. Now, the calculated zenith hourly rate is just a calculated rate if the radiant was at the zenith. So that's a lot. So you can see that you have a 10 times attenuation rate. You lose 90% of your meteors simply because of the city lights. 90% are gone. So don't even bother. So yikes. Oh, but my favorite though, if you look closely, the Geminids. The Geminids are even better. That's in December. Sometimes you go outside in the deepest cold. Find the coldest, clearest sky, and you'll see even better show in December with the Geminids. So, nice thing to do. I'm going to plug the American Meteor Society again. They want you to report fireballs. So let's say something explodes, or like really bright lights. Sometimes these fireballs can be so very, very, very bright that they illuminate the ground. It's amazing to see them, and you can see, and they're amazing. Report it. Go to there. It's a part of a citizen science thing, and that's the way we understand nature of how active a particular shower is. It actually leads to some deeper understanding. By the way, I'm not going to teach anything to anybody. It's like, no, it's very important. So check out this little website. Go to American Meteor Society. It says report a fireball. It's right there. It's fantastic. So where do they come from? This is the source of the Perseid Meteor Shower, Comet 109P Swift-Tuttle. It has a period, goes around the sun roughly once every 133 years. It comes in pretty close, it crosses the Earth's orbit, and there's no chance up until maybe within the year 2126 or later that it would possibly impact the Earth. And if it did, that would be quite bad because it's about the same size as the thing that killed the dinosaurs. So let's hope it doesn't, because that would be a stinker. But how can this produce a meteor shower? So let's actually see what makes up a comet. This is an image of Comet Halley from back in 1986. And what we're seeing is that the sky picture shows a number of things. First, we have two tails for a comet. And they have this large, bright central, what we call coma around the nucleus, which we can't see the nucleus in this picture. But the coma is the bright portion right in the center. And then there's a bunch of dust that's flying off to the right that is essentially being left behind because as the comet travels within the green arrow shows the direction of travel, the dust is simply being left behind and very gently pushed out by the solar wind. However, the plasma tail is going straight away from the sun because as the sun emits a huge amount of light, but it also emits a solar wind. And the solar wind are charged particles that are emitted by the sun all the time, and they're streaming out from the sun in huge waves and amounts. And as they go by the comets, the coma of the comet, they essentially ionize the gas and pull it away. And so it creates two tails. The plasma tail goes directly away from the sun, and the dust tail is minimally affected by the solar radiation, by the solar wind. So this is the other two pieces, but then we now look at an image by the Giotto probe that came within 400 miles roughly of the nucleus of Halley's Comet on March 13th of 1986. You can see that it looks like it's really, really bright in some spots. What this is a piece of ice, a big piece of ice and rock. Well, not much rock though, more ice and frozen gases. And as it gets close to the sun, these gases warm and then sublimate off, and what we're seeing is the bright reflection of the gases that are being sublimated. So this does act like a bit of a jet, and so Halley's Comet tumbles lightly because as it warms, these things just come out explosively from the surface. So when the Giotto probe passed through that, it was actually traveling towards the comet. It actually got hit by some of the material coming off of it and damaged one of the instruments. So let's look a little bit about the nature of an orbit. And so here is Halley's Comet as it orbits the sun. We can see this is taking place, Halley's Comet orbits once every 76 years. And as it orbits, it goes way out past the orbit of Neptune, hangs out there for a long time, and then swings it just very slowly way out past Neptune, and then comes in over a long period of time and swings back in. Well, this simulation shows a continuous tail, which would not be true. The tail only develops when it's close to the sun, as we're going to see in a little bit, but this is pretty typical of a cometary orbit. Comets orbit the sun just like the planets do, just on highly elliptical orbits instead of the circular-ish orbits that we see for most planets. Pluto being a planet, I like to call it that, it's just to rub it in people's faces. Dwarf planet, yuck. Pluto, real planet, me likey. Anyway, so here's Halley's comet going around and around around the sun. But let's look at exactly what's happening here. As a comet starts to fall into the inner solar system, way up on the right, the nucleus is just inactive. It just looks like a ball of ice and rock, but mostly ice. So it'll probably be whitish gray if you went up too close to it. And the nucleus starts to warm and the material starts to sublimate off. Then a gaseous coma, which is just sublimated gases that aren't yet being pushed away from the comet, form around the nucleus. So the coma is like almost like an atmosphere, but more like an exosphere. It's just the gases are simply around the comet, but not well gravitationally bound at all to the comet. And so that's when it gets about within 5 astronomical units, or about 5 times the distance between the Earth and the Sun. That roughly means approximately 500 million miles, or approximately 750 million kilometers. So that's a long ways out yet, but that's when it starts to form and when it gets warm enough for that to approach. When it gets to about 1 astronomical unit, or about the same distance between the Earth and the Sun, the tail starts to form. A tail forms, and that tail is from the solar wind and the solar radiation that pushes the tail out. As it gets closer then, if it gets closer to the sun, then it'll start to fall apart a little bit, and the gas tail is driven by the solar wind, but you'll see that there's a dust tail that's also part of it. And the dust tail is lightly affected by the solar radiation, but it takes a different path away from it, as it just kind of falls away from the direction of the orbit. So it does slightly get affected by the solar radiation, but not the solar wind. And it basically follows a trail. So you get all this stuff that's falling off of the comet as the comet's disintegrating due to being warmed and sublimating away. Finally, the larger particles are not being affected at all by the solar wind or the radiation pressure, and they stay in the orbit trailing behind the comet. So it's just leaving bits behind at this point, like scratching something across a wall, like a piece of chalk across a wall, and it's leaving a line, except this line is in space. So these would become meteors if they do happen to strike the Earth's atmosphere. And then as it passes farther away, it's left some stuff behind in its wake. Some dust has gotten pushed out, and a lot of the gas has gotten pushed out of our solar system. And the comet's tail diminishes as it recedes, and eventually the tail is gone when it goes to about 5 astronomical units. The gases cool again, and they settle out and freeze out on the comet's surface. It's really wonderful. That's what we look for a typical cometary sort of interaction around the sun. And here's some beautiful pictures of Comet Magnat in July 2007. We can definitely see the 2 tails there. Comet Hyakutake in 1996. Comet Lulin that I saw from Inwood Hill Park in northern Manhattan. Kind of looking a little like this, but not this bright. You have to take a really good picture from someplace dark. And I remember Comet Holmes in 2007 looking out my bedroom window in Inwood Hill Park. Now, Comet Holmes also had some wonderful Hubble Space Telescope images taken of it, and the nucleus itself was resolved. And if we look at other comets, such as Schwarzmann-Bachmann 3, we can see that sometimes comets break up into chunks and bits, and those things then become meteors in their own right. So where exactly do comets come from? Comets come from a place, most comets that are 70 or 100 years in orbital parameters come from roughly this place past Neptune called the Kuiper Belt. And the Kuiper Belt is a reservoir of cooler objects. Pluto is just one of the largest objects in the Kuiper Belt. There's a number of objects out there, and some of them are meters across, or tens of meters, and up to many hundreds of miles across, such as Pluto. This was purported to be out there. It was predicted by Gerard Kuiper, and then it was discovered. It was discovered but it was discovered later, and we now know of thousands of objects, hundreds of thousands of objects in the Kuiper Belt past Neptune. And as Neptune goes slowly around the sun, then it gets closer to these objects and perturbs their orbits, and they fall into the inner solar system and then become comets. Some comets, though, are extraordinarily long orbital parameters, and they might live out in the Oort cloud. The Oort cloud is a place that is where a reservoir of comets are, that's almost halfway to the next star or a quarter of the way to the next star. These are extraordinarily far objects. They're still lightly gravitationally bound to the sun, and as the sun orbits the Milky Way and it comes roughly close to another star, maybe a couple of light years away, that tiny gravitational influence from a star a couple light years away that wasn't there thousands of years ago, because the stars moved closer and gotten a little closer to us, then the comets pulled in just a little bit, and then they fall in, and their orbits are perturbed, and they fall into the inner solar system. And we see them come in and out, and sometimes the Oort cloud, named after Jan van Oort, who predicted it a long time ago, these comets have extraordinarily high, either long parabolic arcs, or they might even be hyperbolic, meaning when they come in, they never come back to the inner solar system, ever. So that's kind of fun. I've told you what we think they're made out of, but how do we know? Have we ever been there? And the answer is we've actually been to comets. So there was a flyby. There have been a number of flybys of comets, but let's look at this one, the flyby of Comet Hartley 2 in 2010. This was visited by a spacecraft called Deep Impact, and also was renamed to Epoxy. And this particular one had little bits coming out of it, so you can see what a comet surface looks like in it. It looks like a snowball. It's a dirty snowball with lots of chunks taken out of it. It's a very irregular surface. And we see that if we look at the telescope that they had, if you put filters in front of the detector, you can see that we have evidence for carbon dioxide in those inserts. Carbon dioxide coming off of one side of the nucleus of Comet Hartley 2. Then there's dusty things, that would be infrared, so it shows that there's lots of dust come forward, like little tiny pieces of rock that would be no bigger than dust, really. And then there's water ice, which is the next one. So we know that there's water ice, that's a significant fraction of it. And then there's water vapor, which is sublimated water off of there. So there's a mixture of carbon dioxide ice, water ice, and dust. And those are the principal components of most comets. Now this is very interesting. So where did that come from? And that gets us to a story of the early solar system. And we believe, and we have lots of good reasons to believe, that 4.5 billion years ago, the sun was formed in a cloud of gas and dust, and comets themselves are the leftover products from the earliest times of the solar system that have not interacted with the inner solar system for billions of years. So we can think of Comet Swift-Tuttle or Halley or Hartley 2 as having had nothing to do with the sun for 4.5 billion years, and yet Neptune comes along and whacks it a little bit, and it falls in and starts falling apart. Kind of stinks, right? Makes it sound like it's on its death throes. And yes, some comets actually crash into the sun. They're called sun divers. But in the early solar system, there was a huge cloud of gas and dust. The coolest portions were icy in the outer reaches, and they formed the cometary size. How do we have this? This is an artistic photo, but where do we get this idea from? And we get this idea from looking at young stars and their disks in the constellation Orion, in the Great Orion Nebula, which is a star-forming region. And in fact, we see many such cool disks surrounding young stars in Orion's nebula. And we see these little hot cores surrounded by dark, cool things that we can see simply because of the bright gases that surround them, that they're embedded in. And this is a Hubble Space Telescope image from 1995. We can also see some more deeper close-ups of some of them that look like they have little jets coming out of them and little hoops and things as they move through the nebula of the Orion Nebula, which is an extraordinarily large thing. And you can see there's kind of disk structures. They have like a coma sort of thing. They look like they're little comets that are traveling through. And in their own way, they're kind of comets inside the nebula. But that's not really a good way of thinking about it. There's just extraordinary radiation pressure from extremely bright stars in the center of the cluster, which are distorting the appearance of these things. But off in the quieter sides of there, you will see little undisturbed disks like this with a hot core. And if we zoom in a lot further, we see an edge-on protoplanetary disk. And so this is what the solar system looked like, perhaps 4.6 billion years ago, before the sun even formed, before the planets formed, before the Earth, before Jupiter. It was a huge cloud of gas and dust surrounding a young star. And as that dust formed into planets, the sun went into a more aggressive phase and started blowing the disk apart. And these are also examples of young stellar disks that are being blown apart by they're blowing their cocoon off as the star turns on, begins as a star. And these young stellar objects are quite variable. They brighten and change all the time, and that's because the structure of this gas is always moving. So comets, therefore, came from the beginning of the journey of the creation of the Earth and the sun. They're just little things that are in the back of the fridge that everyone's forgotten about. The sun put them there 4.5 billion years ago, and they've never come out of the fridge until like now. So when you look at a meteor, you're probably looking at a piece of dust that was sitting in the outer solar system for 4.5 billion years and finally made its way around and died in a blaze of light over your head on August 12th, 2023. As it plunged through the Earth's atmosphere, this tiny piece of dust that started in a big cloud of gas and dust in some stellar nursery like the Orion Nebula 4.5 billion years ago. And what you're seeing is the death throes of a little piece of ice and a little piece of rock from that ancient time when the Earth had not yet been born. Have a great time on August 12th. Hope you see some meteors.